Hello everyone, in today's lesson we are going to look at how to obtain the principal argument of a complex number. Now on our screen we have a problem, and in order to solve it, let us start by recalling what we mean by an argument of a complex number z and what it means for this argument to be called the principal argument or the principal angle. We are going to say the argument of a complex number z is equal to a theta. And by definition, this is an angle the complex number z makes with the positive real axis on an Argand diagram. I repeat, this is an angle the complex number z makes with the positive real axis on an Argand diagram. Therefore, if I have z in Cartesian form, okay, now in order to obtain the argument of z, we need to first plot z, okay. So in order to plot z, we have to obtain the real part of z and the imaginary part of z, okay. Afterwards we get the coordinates. So the real part of z is x and the imaginary part of z, which is y. So the coordinates of z are given by x and y, okay. So we can illustrate this on an Argand diagram. So this is the real axis and this is the imaginary axis. But now we said that the real part of z is x and the imaginary part of z is y. Now when we connect the two, we shall find z at this point, okay. So we connect the origin to z, like that, okay. So by definition we said that the argument of a complex number z is the angle z makes with the positive real axis. So we are talking about this angle. And my question is, how are we going to obtain z? It is very simple. We are going to first extract out the right angled triangle, where this is our argument, this is y, and this is x. Now to obtain the value of theta, we are going to use trigonometry, okay. So since this is the opposite of theta, we are going to say tan theta is equal to opposite out of the adjacent. Therefore, tan theta is equal to opposite, which is y, adjacent, which is x. And theta is equal to tan inverse of y out of x, okay. Now, it is clear that any angle measured in this way, we shall have multiple arguments which gives the same value of tan theta. So, to get rid of this problem, we are going to introduce something called the principal argument. So we are going to say theta is the principal argument of our complex number z. If it is measured in radians, theta must lie between negative pi and positive pi. But this theta must be above negative pi and less than or equal to pi when measured in radians. Now, if it is measured in degrees, this theta is expected to lie between 180 degrees to positive 180 degrees. Okay, so this theta must be greater than negative 180 and is supposed to be less than or equal to positive 180 degrees. Now, if we have this information, we are going to solve the problem on our screen. Remember, we say that z is equal to negative surd of 3 plus 3i, implying that the real part of z is equal to negative root 3 and the imaginary part of z is equal to 3. So we draw our Argand diagram and illustrate z. So this is the real axis and this is the imaginary axis. But the real part of z is negative and the imaginary part is positive. So when we connect the two, we shall find z there. Okay, so we draw an arrow connecting the origin and z. So we are going to get this value of theta. Okay, but now we agreed that to obtain theta, we are going to extract out this right angled triangle. Okay, this is 3 and this is root 3. But now we need to obtain alpha. So we are going to say tan alpha is equal to opposite out of the adjacent. So alpha is equal to tan inverse of 3 out of root 3. Let's get our calculators and obtain alpha. So alpha is equal to 60 degrees. But alpha is not our argument. So we are going to say alpha plus theta is equal to 180 degrees. Reason, alpha and theta are angles on a straight line. Therefore, theta is going to be equal to 180 degrees minus 60 degrees. So theta is equal to 120 degrees. Okay, so if we want to get theta in radians, we shall say theta in radians is equal to 120 degrees out of 180 degrees times a pi. So this is equal to 120 divided by 180. This is 2 out of 3 pi. Okay. Example number 2. We have w, which is equal to negative 2 minus 2i, implying that the real part of w is equal to negative 2 and the imaginary part of w is equal to negative 2. So let us draw our Argand diagram. So the real part is negative and the imaginary part is negative. When we connect the two, our complex number W is going to be found in the third quadrant. So this is W, okay? Now we cannot take this angle as our principal argument, but instead we are going to take this one, okay? So to obtain theta, we extract out this right angled triangle. So we say that this is alpha, and now this is a 2, this is a 2. So we are going to say tan of alpha is equal to opposite out of the adjacent. So alpha is equal to tan inverse of 1, where alpha is equal to 45 degrees. But alpha is not our principal argument. So we are going to say the principal argument is equal to negative of 180 degrees minus 45 degrees. I'm saying that theta is negative. Reason being, we are moving in a clockwise direction from the positive row axis up to the complex number W. So theta is equal to negative 125 degrees. Okay, so if we want to obtain theta in radians, we shall say that this is negative 135 degrees out of 180 degrees, everything multiplied with a pi. And this is negative 3 out of 4 pi. Thank you for watching. Don't forget to subscribe, like, and share the video for more about math.